SPH4U, motions in a plane. 1.3, kinematics. There are 5 fundamental kinematic equations that can be used in any kinematics problems. All these should be the view from grade 11 physics. And they're all to the left of the screen here. As well, you should also recall the equations for velocity, which is equal to the change in displacement over the change in time. So this velocity. And also the equation for acceleration. So acceleration is equal to change in velocity over change in time. So delta D, that is equal to displacement. Vf is equal to final velocity. Vi is equal to initial velocity. Delta T is equal to change in time. And A, that is equal to acceleration. Free fall is any motion of a body where gravity is the only force acting on it. And the acceleration is constant, so g is equal to 9.8 meters per second squared down. Yeah, it should be noted that acceleration is positive only when the reference frame is down. If your reference frame is up, then the acceleration will be negative. So negative 9.8 meters per second squared. And the object falls with a constant velocity as air resistance and gravity cancel each other out. Here are a few tips to help solve kinematic problems. So first, you always should establish a reference frame so you know which directions are positive and which directions are negative. And you should also list out all the variables that you have. Then you'll have to find and write down the appropriate equations for the problem, and then you'll have to solve for the unknown. This is an example of an object in free fall, so this will make use of both the concepts of free fall as well as kinematics. So a ball is kicked straight up at a velocity of 13 meters per second. Calculate A, the maximum height, B, the time required to reach max height, C, the time required for the entire trip, and D, the ball's velocity before it hits the ground. So first we're going to set up a reference frame. And we'll make it so that up and right is positive. And here's just a diagram of the motion of this object. So this is at max height. And remember, at max height, the velocity is equal to 0. So right now we're going to list out all the variables that we have. Vi is equal to 13 meters per second up. Vf is equal to 0 meters per second. Acceleration is equal to negative 9.8 meters per second squared, and that's because we have up as our positive reference frame. So we need to find the displacement. So this would use this kinematic equation. Vf squared is equal to Vi squared plus 2a acceleration times d. So that means that 0 squared is equal to 13 squared plus 2 times negative 9.8 all times d. So if we use some algebra, we find that negative 169 over negative 19.6 is equal to d. So that means that 8.6 meters up is equal to max height. Now we need to find the time needed to reach max height. So we know that Vi equals to 13 meters per second up. Know that Vf is equal to 0 meters per second. You know that acceleration is equal to negative 9.8 meters per second squared up. And we know that t is what we need to find. So Vf is equal to Vi plus A delta T. So we know that 0 is equal to 13 plus negative 9.8 times delta T. So that means that negative 13 divided by negative 9.8 is equal to delta T. Therefore, delta T is equal to 1.3 seconds. I just cleared the screen so we have more space to work on part C and part D. So if you recall the diagram that I drew last time on the last page, this is what it looked like, and this was the max height. So this is actually a parabola, which you should remember from math class. So the time it takes to get from origin to max height is actually equal to the time it takes to get from the max height back down to the ground. So that means that delta T total is equal to 2T. So that's equal to 2 times 1.3. Because we knew that it took 1.3 seconds to get to max height. So that means that time total is 2.6 seconds. Here, let's see. Now we'll be moving on to D, the ball's velocity before it hits the ground. So in this case, we're finding the final velocity. So we already know that the initial velocity is 13 meters per second. Up. So, and we know that acceleration is negative 9.8 meters per second squared. And we know that delta T is equal to 2.6 seconds now. So for this, we can just simply use this kinematic equation. So that means that Vf is equal to 13 plus negative 9.8 times 2.6. So Vf is equal to negative 12.48 meters per second up. So it's also equal to 12.48 meters per second down. So that's how you would approach a free fall question, and that's how you'd use the proper kinematic equations to tackle this.